Welcome everyone. In previous session we have discussed about variables, data types in Java and operators in Java. And there are more than 5 operators in Java. We have discussed about only 2, which is unary operator and arithmetic operators. So in today's session we're going to discuss about the remaining operators in Java. Now after unary and arithmetic we're going to discuss about shift operator. So there are 2 types in shift operator. One is left shift and another one is right shift. At first we're going to discuss about left shift operator. The Java left shift operator is used to shift all of the bits in the value to the left side of a specified number of times. Okay, which means if I give a value of 10, which is an int value, so that is gonna convert it into a binary form. Then from that binary form I'm going to shift all the bits in the value to the left side, which means I'm going to remove a bit from the end and gonna add the bit at the start. Okay, that's what we're gonna do in the left shift operator. Let's see a example so that you can understand. Okay, system.out.println of 10 10. This is the left shift operator. Now let's run this. We are getting a value of 20. So how this value of 20 comes from this expression? So let's find out. Okay, in order to convert the decimal or the integer value 10 to the binary form, I need these values: 128, then 64, then 32, 16, and 8, 4, 2, then 1. So now I want to convert the value which is 10 into a binary form. In order to convert to the binary form, this is the procedure. Okay, so I want to find for 10. So if I add 8 and 2, I will get 10. So for this values you will get a bit of 1, while the remaining thing will have zeros. So binary means zeros and ones. So 28 will be 0, 64 will be 0, 32 will be 0, 16 also will be 0, 8 will be 1, 4 will be 0, 2 will be 1, then 0. So 10 has the binary form of 0, 0, 0, 0, 1, 0, 1, 0. So this is the binary form for 10. So now I want to do the left shift of 1, which is I'm going to remove a bit from the left, then add it to the right side. Okay, so I want to remove this bit from the left, then gonna add at the end of the binary code, so which will give us 0, 0, 0, then 1, 0, 1, 0, 0. Now I have to add the bits position of 1 and 1. So this is the third position which has the value of 4. Then this bit 1 position is 5. So the value is 16. So 16 plus 4 will give us 20. So that is the output we are getting here. So this is the use of left shift operator. We are also having 10 left shift of 2, so 2 bits. Then I am increasing the value to 20, then 15 with the 4 bits. Okay, let's try this also. Ten with a bit of 2. So now the value is 40. So the 2 represents the position of the bit. So this is the second position. So I have to multiply the value which we got from the left shift with the 2, which gives us 40. So if the position is 1 means you can just left shift the operator binary code, then you will get a value. Okay. If the bit position is changes means all you need to know is the initial left shifted binary code and its value, then you need to multiply with the position value from here. Okay. So let's try with the different values. 20 left shift of 2. Which is 80. First we need to convert the value into a binary form. So in order to get 20, you have to add 16, then 4. 0, 0, 0, 1, 0, 1, 0, then 0. So for 20, the binary code is 0, 0, 0, 1, 0, 1, 0, 0 was the binary code. Now, instead of finding for the second bit, I have to find for the first bit left shift operator. Instead of finding for the instead of finding for the 2, all you need to do is for the first one. So removing this bit and adding at the end, which will give us 0, 0, 1, 0, 1, 0, 0. I want to add the third bit. I want to add the fourth bit, which is 8. Then the sixth bit, which is 32. So 8 plus 32, which gives us 40. So now I can multiply with the second position value, which is 2 here. So into 2, which gives us 80. So that is the output here. Let's try another one. which is 240. Now let's see. So for 15, the binary code is I have to add all these values. So 8 plus 4 will be 12, then 14, then 15. So 0, 0, 0, 0, 1, 1, 1, 1. So the binary code for 15 is 0, 0, 0, 1, 1, 1. So instead of finding for the 4-bit portion, first I want to find it for the first bit portion. So removing the bit from the left, then adding to the right. 0, 0, 0, 1, 1, 1, 1, 0. Okay, so I want to add the bit portion of 2, 3, 4, 5. So 2, 3, 4, 5 is this. So 16 plus 4, 20. Then 8 plus 2, 10, which gives us 30. Into, I want to find it for the fourth position. Okay. So 1, 2, 3, 4. This is the fourth position into 8, which is 240. So that's the answer here. This is the use of left shift operator. So let's move on to the next shift, which is right shift operator. So the operation is same like the left shift operator. All you need to know is in left shift we are moving the bits from the left to the right. In right shift we will be moving the bits from right to the left. You need to convert the integer to decimal, then you need to shift the bits. Let's see by an example. Okay, so 10 with the bit position 2, 20 with position 2, 20 with position 3. Okay. Right shift, right shift, right shift. Right shift. First let's find for 10 right shift of 1, which is 5. Let's see. We have the value for 10 here. This is the binary form used for the left shift. So 10 right shift of 1 means I want to remove a bit from the right, then add it to the left. So 0, 0, 0, 0, 0, 1, 0, 1. So the bit position of 1 and 3 has to be added. So 4, then 1 is added to get us a value 5. So we are getting 5 here. Let's try for the bit position 2. We are getting the value 2 here. So in left shift, if we want to find the bit position other than 1, we will be multiplying with the value of that particular position. Whereas in right shift, we will be dividing with that value. Okay. So for the second position, I am having a value 2. So I have to divide this by 2, which we get as 2. There is no precise value because I have never declared any data types here. So I am getting a value 2 here. So let's try this. We are getting a value 5. So we have the binary code for 20. All we need to do is do the right shift. 0 0 0 0 1 0 1 0. I have to add the second bit and fourth bit position. So second bit and the fourth bit position is 8 and 2. So we get the value 10. I want to find the second bit left shift operator. So I have to divide by 2, which we get 5. We are getting the value 5. The last one is we need to find it for the third bit position, which is getting us 2. So 10 divided by the third bit position, which is here, and its value is 4. So 10 by 4 we get 2, and that's the answer for the last one also. So this is the use of left and right shift operators. So for left shift operator, you need to remove a bit from the left and add it at the end of the code, binary code. And for the right shift, you need to remove a bit from the right, then add it to the left end of the binary code. In order to find different position except one, initially you have to find it for the first left shift or right shift operator. Then depending upon the position, for left shift you will be multiplying with the position value, and for the right shift you will be dividing the value with that position value. Okay, so these are shift operators in Java. The next is bitwise operator. It works on bits and perform bit by bit operations. So like shift operators, we need to convert the values into a binary code. Okay, there are 4 operators in bitwise. One is AND operator, another one is OR, another one is XOR, then we have NOT operator. So these are the 4 operators we are gonna use in bitwise. For example, we have A equal to 60 and B equal to 30, and we also have binary code for both the values. Before we get into the example, let's see how AND, OR, XOR and NOT will perform. For AND operator, so this is the AND operator. So the condition for AND operator is if both the input is true, then the output will be true. Okay, so if both the value is 1, then the output will be 1. That is the condition for AND operator. You'll get 0 0 0 will get 1. This is for an operator. The next one is OR operator. The condition for OR operator is if any of the two inputs is true, then the output will be true. Okay. 0 get 1 because it has one true input. 1 and 1. Then you wanna look at XOR. So for XOR, if any of the one output is true, then the output will be true. Whereas if both the input is true or 1 then the output will be 0. If both output is 0, then the output will be 0. This is for XOR. This is NOT operator. So NOT operator is simple, which will inverse the input. If the value is true, then the output will be false. If the value is true, then the output will be false. So it will invert the input. Okay, these are the operators we're gonna use in the bitwise operators. So AND, OR, XOR, then NOT. So let's find the values using the 4 operations. Okay. We have A of 60 with a binary code 00 11 then 1100. So this is for A, and we have B of 13. Value 000 then 1101. So let's before we that. So int A equal to 16, then B equal to 13. So system dot out print ln of A and B. Okay. So let's find 0 0 and B has 0. Zero and 0. We have 1 there is 0. We have 1, 0. We have 1, here 1, 1, 1, here 0, there also 0, here 0, here 1. Okay. So for the AND operator, the condition is both the input has to be true for the output to be true. Okay, 0, 0, which will give 0. So 0, 0 will give 0, 0, 0, 1, 0, 1, will also give 1, 0, 1, 0. So to find the value from the binary code, we need to add the position of these two values, which is here and here. So this is 1, 2, 4, 8. So the value has to be A and P means the value has to be 12. Let's check whether it is correct or not. Okay. So I have given two inputs A and B here. Then printing A and B. The output is 12. Okay, that's how and bitwise operator works. Let's try. So for the OR operator, any of the two input has to be true for the output to be true. So for the first one, you get a value of 0. For second, 0. You will get 1, 1, 1, 1, 0, then 1. Okay. Now I want to add the bit portion of these names. This is 1, this is 4, then 8, 16, 32. 32 and 8 will give us 40. 16 plus 4 will give us 20. So 40 plus 20 will give us 60, then 1. So A or will give us 61 as the answer. So let's go with that. We are getting a value 61. Then for the XOR, any of the one input has to be true to be the value of output to be true. Okay. If both the input is 1, 1 or 0, 0, then output will be 0. For the first one, we will get a value 0. For the next one also we will get 0. For this, we will get a value 1. For this also, it's 1, 0, 0, 0, then 1. So this is 16 and this is 32. So 16 plus 32 will give us 48. then 149. Let's check whether it is correct or not. So 49 is the answer. Okay. Here will give us 49. So for the next one is will give us minus 61 because it will just invoke the value, which means if the value is positive, then the output will be negative. So minus 61. I'm getting the minus 61. So this is how the AND or XOR and NOT operator works in Java. So there is another example for the value 40 and 15. So what will be those values? A is 40, and B is 15. We need to find the values then. I'm doing some left shift and right shift also. A of left shift. So for the first one we are getting the output 8, and for OR operator 47, XOR 39, then for left shift for 1 we are getting 80, for the 2 we are getting 160, then for the right shift for the 1 we are getting 20, for the 2 we are getting 10. Okay. The next operator we're going to see is ternary operator. Okay. This operator consists of three operands and is used to evaluate Boolean expressions. So this ternary operator can be used instead of if else statements. So those condition statement we will be learning in further sessions. So this is a one line replacement for the if else statements. So instead of we go to the if else, we can use this ternary operator for the programming. And it is the only condition operators which takes three operands. Okay. And the goal of this ternary operator is to decide which value should be assigned to the variables. So this is the syntax: variable and variable name equal to, and the expression which is a condition, then a question mark which is the operator, then value if it is true, then a colon, value is false. So this is the operands we're going to use in the ternary operator. So it will check the condition. If the condition is true, it will print the value, or else it will print the another value. So this is what we will be using in the if statement, if else statement. So instead of going for multiple lines, the ternary operator will complete the operation in a one liner. Okay. So let's see with an example. We are getting two variables, int a and int b. I want to have another variable. I want to find which is the minimum value. So we know the syntax, right? Variable name equal to an expression, which is a condition. A is less than b. This is the condition. Then the operand we are using. I want to print A else b. So which means if the condition is true, I want to print the value A. If the condition is false, I want to print the value B. So system dot out dot print ln. I want to print min, which is minimum value. So I'm getting the minimum value, which is 15 here. So the condition is false. It will print the value B here. So this is the use of ternary operator. The next one is assignment operator. So assignment operator is nothing but the equal sign. Okay. This is used to assign any value to the variables. The general syntax is variable equal to value. So equal to the operator here. We can also use assignment operator for the compound statements. So what do you mean by a compound statement? So instead of using a plus 4, so 44. Instead of using this compound statements, so this is the compound statements. I can use a plus equal to 4. So we can get the same results using this operation. Instead of going through the normal way, we can use this as the assignment operators. We can perform those arithmetic operations like add, subtract, and multiply, divide, all these operations using this way of assignment operator. Next one is relational operators. So these operators are used to check for a relation like equal, greater than, less than. Okay, so equal to, not equal to, greater than, less than, greater than, or equal to, less than or equal to. These operations are performed using the relational operator. So some of the relational operators here, like I said, equal to, it will return true if left hand side and the right hand side are equal. Whereas not equal to returns true if left hand side is not equal to the right hand side. And we have less than, then we have less than or equal to, greater than or equal to. Okay, these are some of the examples for using relational operators. So these are the operators we're gonna use in Java. We have seen unary, then we have seen arithmetic, then we have seen shift operator and bitwise, then ternary operator, then assignment, then relational operators. So these are the some of the operators in Java. So let's do some programs using the operators and what we learned from the previous sessions. Okay, write a program to do arithmetic operations, swap two variables, then swap two variables without using a third variable. So for the first one, which is arithmetic operations. For add, then minus, then multiply, then divide, then mod, divide, then mod. So the value has to be 55, 25, I think. I think 600. So 55, 25, 600, and 2, then 10. So these are to perform arithmetic operations. The next one is we're gonna swap two variables. Int a equal to 40 and b equal to 15. I want to swap these two variables. So for that I am using another temporary variables. So assigning the temp with a. So a equal to b and b equal to temp. So before that we need to print the values a. I have to swap it. So before swapping, we have A equal to 40, then B equal to 15. After swapping, the A value is 15 and B value is 40. This is using a third variable. So let's do without a third variable. Okay, for that, A equal to A plus B. B equal to A minus B. A equal to A plus B, I think. Let's try. A minus B here. So A is 40, then B is 15. After swapping, A is 15, then B is 40. So this is how we can swap two variables without a third variable. Okay. So the session for today is over. We will meet you on the next class.